Hello viewers and my dear students, welcome to session 4 on projection of plane surfaces demo. We have started with a demo on Square Lamina in the earlier session. We'll continue this, and this demo and all that we are using Solid Edge tool to complete. This demo is purely using Solid Edge. See here, using Solid Edge, we had come till this point in the last session. That means it's a square lamina of sides 40, and I told you square lamina, you have edge position separate, corner position separate. Since corner is on HP, we have taken this position. Okay, but this is plus 45, this is minus 45 in that way, as I told you. But if it is edge position, one of the edges should be perpendicular to XY line. Okay, so that edges on HP means this one of the edges should be perpendicular to XY line. Please read to all this in the my sessions on projection of plane surfaces. Okay, now it is only teaching how to do this problem in Solid Edge and all that. Okay, now as you see here, right now what we have done is a square lamina. Right now the complete square lamina is on HP. A, B, C, D. I got the front view corresponding. B is seen, D is away, B dash, D dash, C dash, and this is A dash. Okay. Now this is an imaginary diagonal which is parallel to VP. Okay. Now even if you pull this up, when you make it inclined at 30 degrees to HP, this diagonal is still parallel to VP only. Okay, this diagonal is still parallel to VP only. As a result, in fact, it will be lying on VP. Okay, when it is inclined at 30 degrees to HP, this diagonal, this AC, is still parallel to VP, that is lying on VP itself. The true length is seen here. This true length and this true length same. That's why this first stage front view and second stage front view are same. That is why we move, copy and rotate in such a way that this inclined at 30 degrees to HP we are done, and we have got the projectors from here, and I got the locators here A, B, C, D and all that. This is the thing, and whatever is extra and all that you can trim it off here. Okay, trimmed it off. Now you see here, when the square lamina has a corner on HP, surface or diagonal inclined at 30 degrees to HP, when you are looking from the top, this is how it appears. All lengths A, B, B, C, C, D, D, A have all reduced because they are all inclined to HP. Okay, as they are inclined to HP, in the top view it reduces. Okay, this is initial position. Now I have started the problem. The initial position you do this way, then they are given one diagonal is inclined at 30 degrees to HP. See here, they have given with where diagonal contains this corner inclined at 30 degrees to HP. That is why diagonal contains the corner is AC only, no? The diagonal contains the corner on HP is AC only. This is it is resting on A. AC is the diagonal contains the corner. That is AC is inclined at 30 degrees to HP. You get this. Now what they say is, here this diagonal is in true length actually. If I say other diagonal perpendicular to the previous inclined at 45 degrees to VP means other diagonal perpendicular to the previous is this. This is in true length. I would have made BD inclined at 45 degrees to VP. If I say other diagonal perpendicular to the previous, that means this BD only, parallel to VP means I would have made BD parallel to VP. Okay. But here they have given a different sentence altogether. You see here, and the top view of this diagonal is inclined at 45 degrees to VP. With the diagonal contains this corner inclined at 30 degrees to HP, and the top view of this diagonal is inclined at 45 degrees to VP means the top view of this diagonal is AC. Okay, the top view of this diagonal is AC. That means this is reduced. It is not in true length. The top view is AC. That should be inclined at how much to VP? You see, 45 degree. Okay, now what I'll do, this AC should be inclined at 45 degrees to VP. What I'll do is, first I'll move. I take move command. I'll take the entire thing. Okay, I take the entire thing and see that this is on. Move and copy, no? Because this should be there. Take one point here, reference. Here you take. And I put escape. Now it has come here. Now, if you want to have a reference, okay. Now this, now what exactly you should know here is the top view of the diagonal contain the corner is AC. This should be inclined at 45 degrees to VP. Okay. Now what I'll do, I'll go for rotate, and I'll not copy with this as a thing, and this as the moving point. This is a fixed point, this is the moving point. I'll rotate this. You see here, I want the rotation angle to be 45. You do this 45. Okay. Now once you do this 45, this AC, the top view, this is not in true length. I'm telling you this is in true length. But what they're given the problem is, top view of the diagonal contains the corner on HP. That is, AC is inclined at 45 degrees to VP. In that way, you can just do this. Okay, this is the 45 degrees to VP it should be. Now you do what you do, no? You measure this. Okay, this you do 45 degrees to VP it should be. In that way, this top view of the diagonal contains the corner is inclined at 45 degrees to VP. What I done is, I moved, copy and rotated, and such that AC, which is not in true length, please understand, AC is inclined at 45 degrees. It is not the true length of the axis, which is the true length of the diagonal, which is inclined at 45. What they are given the problem is, top view of the diagonal contain the corner is inclined at 45 degrees to VP. In that way, top view of the diagonal contain the corner is AC. It is a top view. It is not the true length. Top view is inclined at 45 degrees to VP. It takes it. This second stage top view and third stage top view are same. See here, as long as inclination to is kept constant, okay, the top view won't change. Now what I've done is, I have rotated this lamina about A such that AC is inclined at 45 degrees to VP. But I have moved this corner or rotated this corner to the left, or you can even do the right. But in the process, inclination to HP 30 degree I have maintained constant. I have not changed it. It is the 30 degrees to HP is constant. That means A as the fixed point, C as the rotating point. I can move this way or I can move this way. I have moved this way. As you see here, I moved this way such that AC is inclined at 45 degrees to VP. Okay. You can do this way also. There is no problem at all. In which case, this is lamina leaning towards the observer. Now it is what I have done here is I moved that way. Lamina is leaning away from the observer. That is the only thing. You can move this way or that way. But in the entire this thing, you should know very well, surface inclined at 30 degrees to HP is constant. Here 30 surface inclined at a diagonal inclined at 30 degrees to HP. Here also, this is the same top view I have taken here. The diagonal contains the corner on HP is 30 degrees to HP, but at the same time, the diagonal is inclined, the top view of the diagonal is inclined at 45 degrees to VP also is there. Okay, this is the problem. Okay, remember this. This, as soon as you see this, this is corner on HP. Diagonal contains the corner inclined at 30 degrees to HP. This top view and this top view is same. But I have rotated about a corner A this way so that the diagonal contains the corner at 30 degrees to HP is maintained constant. But only thing is, in this position, diagonal was parallel to VP. Now I have made inclined at the top view of the diagonal contains the corner, that is AC is inclined at 45 degrees to VP I have made. That's the change. Okay. Now you see here, this you do, take the projectors. Okay, you take all these things. Okay, once you do all this, take the points here. Now using the point command, no? Point command, take 2 mm. You just see C should be somewhere here. I think C is here. Okay, C is here. And if you go here, somewhere here, it is B. Somewhere here it is D. Okay, and somewhere here it is A. Somewhere here it is A. Now if you want to clearly know, okay, you can enlarge this. Okay, now using line command and take 0.5. Okay, in that way I have done it. Okay, now once you do this, this is the problem, and you can name the corners also. A dash, B dash, C dash, D dash also. Do all this and push it to the respective corners. Now it is, hope you know, this is A dash, this is B dash, this is C dash, this is D dash. In that way, you have completed this problem where as soon as you look at the problem, I'm telling you, be careful. These things are so important from the examination point of view and all that, and understanding point of view. You should know what exactly is the subject. XY line VP HP. I drawn 40 mm square lamina corner position. As soon as you look at that corner and HP, diagonal or surface inclined at 30 degrees to HP. Now, when it is in this position, when you're looking from the top, this is how it appears. All lengths would have reduced. The square lamina, when it is tilted over a corner, such that the diagonal AC is inclined at 30 degree, a surface inclined at 30 degree, all lengths would have reduced. It's a small one. That means it all apparent lengths. It looks smaller. Now keeping inclination constant. That means the second stage top view and third stage top view will be same. Keeping inclination constant, I have rotated about A only, because the top view of the diagonal container corner is AC. That should be inclined at 45 degrees to VP, they have said. That is why I've with A as the fixed point, C as the moving point, I moved this way. When lamina is leaning away from the observer, I can move it this way. Lamina is leaning towards the observer, and now I have done lamina leaning away from the observer. In the entire process, surface inclination to HP is kept constant. Now I have moved it into this position, that is such that the top view of AC, top view of the diagonal container corner is inclined at 45 degrees to VP. In this position, in this complex position, means you should understand surface or diagonal inclined at 30 degrees to HP. Okay, diagonal the corner is on HP. Diagonal contain the corner or surface inclined at 30 degrees to HP, and the top view of the diagonal contain the corner is inclined at 45 degrees to AP. Looking at these things, you yourself should be in a position to frame the problem yourself. In this position, in this complex position, you have written the front view. Front view looks like this, top view looks like this. This is called change of position method. This totally, because we first position will have it this way, true things you do. Next, I'll rotate for 30 degrees, the HP inclination I'll give. Next, I'll give VP inclination. This position is called change of position method. In that way, we have completed a problem on a square lamina in this session 4. We'll continue in session 5, again demo problems on some of the laminae. Thank you very much for watching. Thanks friends. Thank you.